Hello, I welcome you once again to my YouTube channel. It is still your tutor, Peter Ekaja, and we are here today to continue with the next tutorial, particularly emphasizing on partial fractions. Now, partial fractions as a method is actually always used to integrate proper fractions of polynomials whose denominator is a product of factors. What is very important to note here is that we use them to integrate proper fractions. And when I talk about a proper fraction, it is important to know that a proper fraction is that whose degree of the numerator is less than the degree of the denominator. What I mean in this case is if your fraction is in terms of x, then the highest power of x in the numerator must strictly be less than the highest power of x in the denominator. Otherwise, it becomes improper. And that will be handled later on as we move on with our tutorials. Now, we basically have three types of partial fractions. One of them is type 1. And when we talk about type 1, we shall be considering those that have a denominator with only linear factors. Linear factors. And when I talk about linear factors, these are factors of the form a x plus b. That means strictly the power of x must be 1, or the factor must take the general form of a straight line equation. Type 2, that is another type where we have the denominator with a quadratic factor. And then type 3, that's also another type where we have a factor with a repeated factor. I will break down these types one at a go to make this so simple for us to understand. So let's begin right away with type 1 in today's tutorial. Okay, now in our type 1, we're beginning with one simple example here. It says express 11x plus 12 divided by 2x plus 3 into x plus 2 into x minus 3 into partial fractions. Hence find the integral of that same expression. Now, something very special to note before you start is to first realize that the highest power of x in the numerator is 1. And then if we open the brackets that we have in the denominator, the highest power of x would be 3. 1 is less than 3, and therefore this qualifies to be a proper fraction. So we can comfortably begin by considering this as a type 1 problem. So what do we do with this? We begin by letting. We say let 11x plus 12 divided by 2x plus 3 into brackets x plus 2 into brackets x minus 3 to be equal, or we can use an equivalent sign. We say a is just a constant unknown which we shall look for, divided by our first factor, which is 2x plus 3, plus you go to b. B is x plus 2. B is divided by the second factor, which is x plus 2. And then finally, c is going to be divided by the third factor, which is x minus 3. Now, what you now need to realize here is that when you get the LCM of the right-hand side, it becomes the same as the denominator of the left-hand side. And therefore, they will cancel out. So the next step now becomes 11x plus 12 is equals to a. Now, to get what we're going to multiply by a, we get the LCM, which is 2x plus 3 into x plus 2 into x minus 3 divided by 2x plus 3. We remain with x plus 2 into brackets x minus 3. We go to b. We get the LCM again, divided by x plus 2. So we shall remain with 2x plus 3 into brackets x minus 3. And finally c. We get the LCM divided by x minus 3. So we shall remain with 2x plus 3 into brackets x plus 2. So that would be one important step that we can proceed with. Then from here, we are going to equate each of the factors to 0 to get the values of x that will help us proceed. And as we do that, we call it the cover-up method. You cover up two constants to be able to get one of them, and you do it one at a go. So let's proceed and do that. So we're going to begin by considering the first factor, which is x plus 2. When we equate this factor to 0, it will give us x equals to negative 2. That means we shall begin by saying substituting x equals to negative 2. You substitute on the left-hand side and on the right-hand side. You make sure you place negative 2 in the place of x. The beauty of doing this is that the whole of this first term becomes 0 because we have x plus 2. So when you put x as negative 2, negative 2 plus 2 will be 0. So the whole term becomes 0. The third term, which also has x plus 2, the whole of it becomes 0. So on the left, definitely when you put negative 2, we shall have 11 times negative 2, which is negative 22, plus 12. And when you do that, definitely you will get negative 10 on the left-hand side. So we shall have minus 10. On the right-hand side, when you substitute negative 2 in the place of x here, you also substitute in the place of x here. The final answer you will come up with will be 5b. And that means the value of b becomes minus 2. So after getting minus 2 for b, we now move the next factor. Get x minus 3 and equate it to 0. That means it gives us x as 3. So we shall say substituting x equals to 3. When you put x equals 3, both left-hand side and right-hand side in the place of x, you are expected to come up with 45 on the left-hand side. And on the right-hand side, you're expected to come up with 45c. That means the value of c is going to be 1. The value of c will be 1. And then finally, we can now substitute. For x equals to negative 3 out of 2. How did we get it? We equated 2x plus 3 to 0 and obtained that value. What happens when you do that? On the left-hand side, if you substitute carefully in the place of x, you'll get negative 9 out of 2 is equals to negative 9 out of 4a. And therefore, if you're to make a the subject or get the value of a, the value of a becomes 2. So after getting the value of a, b, and c, we comfortably substitute them in our very first step. So we can conclude and say, therefore, 11x plus 12 divided by 2x plus 3 into brackets x plus 2 into brackets x minus 3 is actually equals to a, but our a is 2, divided by 2x plus 3 plus b, but our b is negative 2. So instead of saying plus, by the way, I can even say minus 2. Plus negative means you can have a minus dominating. So I can say minus 2 out of x plus 2. And then finally, plus the value of c, which is 1, but out of x minus 3. So what we have done so far is we have expressed that fraction as a partial fraction. But then we had in our question the other part that says we also integrate the whole of this function. So to integrate the whole of this function here, we shall simply integrate the simpler fractions we have come up with. So we can proceed, but before, of course, you proceed with the integration, you should remember the skills of integration in our previous tutorials. That means you should have gone through all the previous tutorials to be comfortable here. So I can comfortably say that now integral of 11x plus 12 divided by 2x plus 3 into brackets x plus 2 into brackets x minus 3. All this with respect to x is just equals to integral of 2 divided by 2x plus 3 with respect to x minus integral of 2 out of x plus 2 with respect to x plus integral of 1 out of x minus 3 with respect to x. So you can have them with individual integrals, or you can have an integral for all of them, but then you maintain the principles of integration carefully. Now, when we integrate 2 out of 2x plus 3 dx, I just refer you to integrals of the form f prime of x divided by f of x with respect to x. That is one of the tutorials I already have on my YouTube channel. The answer we get in this case will simply be ln or natural log of 2x plus 3. How does this come? When you pull out the 2 and you remain with 1 over 2x plus 3, to integrate 1 over 2x plus 3, you get a half ln of 2x plus 3. But then the 2 will cancel out with the 2 and giving us this result. The next one, when you pull out the 2, it will be 1 over x plus 2, which is giving you a ln of x plus 2. So it will be 2 ln of x plus 2. And then finally, when you integrate 1 over x minus 3, the answer will be a ln of x minus 3. In this case, a ln is just a natural logarithm. And then plus our constant of integration, because our integral did not have the limits. So this is how we handle carefully type 1. And in this tutorial, we're going to maintain this example, but see you in the next tutorial, whereby I will also add on 1 or 2 examples about this before we go to the next type. Remember, I also do one-on-one online teaching. We serve learners from any part of the world. In case you find need for that, in case you find a relative who needs that, in case you find a brother or sister, we are always available. Kindly contact me using any of the contacts +256 70 0799 or +256 784 79 23 69. So these contacts are all on WhatsApp, and therefore I can catch up with you anytime. I also have a website, and that website is called peterekaja.com. So you can also reach out to us there and find the best of our services. See you in the next tutorial. Bye bye.